What does the creator of UML think about modern architectures and how we do programming? Let's get into it. Hi, I'm Chris Tennis. That was a rough start. Tech support's coming out Tuesday, uh, and yeah, we're gonna listen. I heard about this Grady Booch guy, and he's like, "Oh, UML." He came up right as I was kind of leaving. I had an exit from my first startup, and he was kind of becoming a little bit popular. Maybe a little bit before that, but I was doing a whole other branch of software development. He was doing more enterprise level stuff, which his UML diagrams kind of made sense, but people took it way too far. They were like, "This is going to replace software engineering. Just anybody can get involved. They can read the diagrams and go right to code, right to code." It's like, I don't think so. So if it turns out the software engineering to define what we want the machine to do for human standards, it's a lot more than the little picture diagrams. It's a lot more than that. Now, high level for engineering to get an idea like what we're trying to put things together. Yeah, it might be useful as a thumbnail sketch, kind of a flow diagram, how things are put together. But the actual diagram, all these little symbols and what they mean, it's like, oh man, kind of losing the script there. All right, let's get into what he has to say.
The entire history of software engineering is one of rising levels of abstraction. So what we're seeing here is the rise of another level of abstractions, which gives us all these extraordinarily powerful frameworks from which I can build systems, in which, as I alluded to, the architectural decisions that were front and center for us back then are now embodied in these. So now becomes a decision, what cloud service do I use? What messaging system do I use? What platform do I use? That's the decision, which has a lot of economic decisions and not just software kinds of decisions associated with it.
Oh, wait a second. Okay, I gotta stop. I'm gonna do a watch along. So this might be a two-parter. This might go on for a while. I've been putting this off because I figured he'd be saying stuff like this. But like, okay, what does he say?
The decision, which has a lot of economic decisions and not just software kinds of
So software decisions are economic. I'm surprised. Software decisions are economic decisions. There's people going to work. There's people putting in hours. There's alternatives. There's other technologies. Can we leverage something that exists? Is there a free open source system that like we can use instead of $50 million a year versus some new system that has some high performance thing that we need to roll from scratch that'll cost us a few $1 million a year, the few $1 million a year that we may be able to use in the future to give to somebody else. I mean, all these are economic decisions. What is it? This guy is a fellow at IBM. Okay, let's keep going on. I'm gonna stave off my judgment, but I'm already getting juiced up on just what he said so far.
decisions associated with it. So I think the role of the architect, in effect, has changed because now I'm dealing with systemic problems, not just software problems themselves.
Wait. Software problems are system problems. Holy crap. Like, we are mimicking we're doing human stuff. We're just not an abstract computing machine. We're trying to fix human problems, guy. Wait, okay, let's keep
Grady
going.
Booch is a trailblazer in software engineering. He built his first computer 57 years ago at just the age of 12, and is known for his decades-long work in advancing the field of software engineering and software architecture. He is the co-author of UML and has originated the term and practice of object-oriented analysis and design. He's an IBM Fellow, an ACM Fellow, and has been awarded several other prestigious awards for his work in software architecture. He's the author of 6 books and more than 100 technical papers on software.
Yes, he's well known.
In this conversation, we cover the first 2 golden ages of software engineering, how UML was created and why Grady disagrees with how it has evolved since version 1.0, how the practice of software architecture has changed over time, Grady's views on large language models, interesting stories like how Grady was offered to be Microsoft's chief architect but said no to Bill Gates, and a lot more.
Okay, that's respectable.
If you enjoy the show, please
I'll give him props for that.
subscribe to our podcast on any podcast platform and on YouTube.
Yeah.
It's safe to say I'm talking with a living legend in the field of software engineering, so welcome to the podcast.
Emphasis on living. I'm not done yet. Yes.
Absolutely. So to kick off, you're a chief scientist at IBM. That's a pretty fancy title. What does it mean, and what do you do? I'm curious to know.
Well, there was a time that my business card said I was a free radical, but upper management didn't like that, so I had to find something a little bit more tame.
I appreciate
Actually,
that.
the more important title / position is that of fellow. There are, I think, 68 of us still active. No, 89 of us still active, and this has been out of 350 or thereabouts fellow.
So my ex-wife, one of her cousins was a fellow. Our uncle's was a fellow at IBM, and I got to chew his brain. I didn't really impress me as being all that into it, but he was into like super database stuff, and I'm into like graphics and mobile and all this other crazy stuff. So we kind of didn't see a lot of. I got a lot of stuff. I just didn't understand what he was talking about.
Throughout the history of IBM, so we're a fairly rare breed. I was made a fellow upon the acquisition of our company, Rational Software, back in 2003. And the great thing about being a fellow is it's rather like having tenure, meaning we trust you've done good things. We want you to continue doing things. Let's give you the degrees of freedom to do that. And so, as a fellow, and with my focus upon first software engineering and then later upon AI, I am given a lot of degrees of freedom to pursue what I think makes a lot of sense to try to, as Alan Kay would say, invent the future.
Oh yeah, I'll give him props. He's brought up Alan Kay, so yes, he's got some. He sees where these things can head and lead, and okay, that's cool.
So, in my journey from starting at
I'm a big fan of
2003,
Alan Kay.
I first stayed with the rational division, but then quickly moved over to research because IBM's bureaucracy realized I was a person who worried about the next 5 to 10 years, not the next quarter. And indeed, my very early work in research was looking at finding ways to automate the discovery of patterns within legacy software systems. This is
So machine language statistical analysis. That's cool, I guess. I mean, but is that all we're doing with this? AI is just statistical analysis. I mean, it's easy to do. It's because columns of numbers you can add them together, run it through the neural processor, randomize it to see if it's getting better or worse, and go off in that direction. Okay, but that's not really. I mean, it's pattern matching, yes, but it's not really intelligence. I mean, I guess it's a kind of. It's impressive. Humans have a real hard time with it. But so yeah, I mean that's cool and everything. But let's keep going, Chris.
Something we were doing pre-neural network days, and it was interesting trying to see if we could discern the design patterns from the Gang of Four and elsewhere. It never went anywhere because it was a hard problem.
Yeah.
And so I then began to, in the architecture
Big
sense
time.
of things, I worked with a lot of customers, and actually I've been doing that for decades, where I'd be parachuted in, the customer would say, come help me, Mr. Wizard, with this particular architectural problem. And the exciting thing about it for me is that for many decades, I was engaged in projects across every conceivable domain.
That's cool.
And I'll pause there to say that roughly around the turn of 2010-ish is when I began to be drawn back into the space of AI.
So when you say you worked on legacy systems, what does a legacy system?
That's when I got into the mobile side. I was thinking about getting to mobile at that point. He's getting to the AI side, but he's like more like, I think he's talking about machine learning, or this current version of it. Let's be a little specific. Like he's talking about the sci-fi AI. He's talking about what could be, what actually is computable given a trillion times more resources, or is it this machine language what we could do on computers today in the next 5 years or 3 years, whatever, where we can do pattern matching? Is that what we're talking about?
System mean to you?
Well, the moment you write a line of code, it becomes a legacy system until you throw it away.
Yes, of course.
So
every line's a bug.
All code to some degree is a legacy system.
Yes,
Facebook is a legacy domain. Google is legacy. Heavens, even OpenAI has a legacy problem. Because reality is that,
of course, because what do you expect? Do engines and cars have a legacy problem? Yeah. They were fit for the purpose at the time, given the engineering resources they had available and the skills they could put together to muster up that particular thing. There were many other attempts that didn't make it. And so those are the ones that worked. So are those legacy?
And say, old code never dies. You have to kill it.
No, you don't kill it. No, who's got killing code? It just sits there, abandoned. Code is abandoned. No one's out there killing it. Kill it. Kill the code. No, it's just not read anymore, not executed anymore, not looked at, not updated. Just bits floating around that no one's looking at, nobody cares about, nobody. That's how it dies. What the heck? Like, we're gonna kill it. No.
Once you have built something that's useful, then it's going to live on. And so
as long as it's useful. As long as it's useful, it will live on. And that's who's useful. Who's it useful for? Humans solving human problems. So there's another way to do it, a better way to do it, a more easy way to do it. Doesn't require $1 billion or someone's permission or some licensing agreement, and all that stuff. Well, yeah, they're going to start doing that instead. What are you talking about? This is how humans have been doing stuff. That's the whole industrial revolution. Is like figuring out ways to increase some productivity, solving some problem easier and faster, more fun, more friendly than something else that sucks. And once you see the new things, like, yeah, that thing sucks. I've been getting into DJI drones lately. I first got to drones back in the 2000s or so, and they were terrible. You had to manually control them, like the old helicopters, where you had to manually control. You had to be super highly skilled. You're going to spend at least $10,000 crashing these damn things. So I was really got into that. So I gave them up. I came back into it about 6 or 7 years later, and they had the hover thing, and you could kind of control it, but there was like no screens. So you had to look at the thing. It's like, okay, so I got another DJI drone lately, and it's like, oh, okay, they solved a bunch of stuff now. It's like really hard to crash. It's got 360-degree sensing. You really have to try to crash it. Otherwise, it'll be a warning. You turn off all the warnings. You turn everything off. To put it in super sport mode before you can crash anything. And then it's like warning. It's like it flashes warnings all the time. So it's like you have to be like really dumb to try and crash or being intentional. So they, yep, okay, so they came come a long way. That's legit.
fully disposable code.
I don't know.
There
I'm
is
telling you the
some body
stories.
of
I don't
code that
know.
you have there that represents something immutable, something that has a cost, something that has.
All right, I was trying to get the, as long as it's useful, people will use it. That was my point. Yes, that's where I was going with that. As long as it's useful, they'll use it. But those old drones, nobody wants those things anymore. They're sitting, there's piles of them. I couldn't get rid of my thing fast enough. I'm like, this is crap. But now they have these ones that are hard to crash. They're super fun to fly. They give you all the warnings. They come back to home automatically. They're precise landings. It'll land right where you dropped it. Yeah. Now, then something else better comes along. You better believe I'm getting rid of those things. That's how this all works. And those are all software, by the way. The hardware has been the hardware has not changed. The battery, the motor. I mean, they've got it tweaked so they can do a little like 20% faster, whatever. But it's the same shit that they had back in 2000. All it's changed is the software, sir.
Some degree of technical debt to it. It may be very, very small. If you look at many of the classic organizations,
Technical debt is immediately when you realize there's something better. So technical debt for me means that, okay, so right now I've got this drone, right? This DJI drone that works and great, does everything I want. But what happens if tomorrow they come out with one that's even smaller and goes twice as far? And it has even more intense location. You actually can't, it's impossible to crash it because it's 3D LiDAR at night, day, anytime, fog, rain, whatever. Well, then my current drone becomes technical debt because I realize there's something else better that will serve my needs better, or maybe not. I mean, I'll be aware that this is now technical debt, that there's something else better that's the best in all the categories. Like how all these phones got bested by the phones got bested all the cameras. There's no camera photography's dead. It's going. It'll be gone. And then the pricing of the old equipment is going up because people are realizing it's gone. They're like, oh my eye, look, I can't get a camera anymore. It's like, yeah, that's gonna be gone because the cell phones kicked it. So big body cell cameras are technical debt. There's a whole series of technical debts that have been destroyed. Like the whole film camera industry is like completely decimated. The moment the digital stuff bested it. That's technical debt.
in the big financial space,
And that's the actual definition from the actual. I've another show on my channel if you want to go look into my stuff about technical debt, what it is, who invented the term, and what it actually means.
groups who've been working with code bases since literally the 60s. I had one
Now the way a lot of people use it is like, oh, it's just old code that's hard to change and can't figure out because people left and we fired them and there was three rounds of layoffs ago and we have no idea how this stuff works. That's technical debt. No, not really. No, that's just screwed up practices and abusive humanity. Like that people want to move on because you're just so abusive to their minds and their souls and how you treat them. That's the debt.
Engagement with the Internal Revenue Service in the United States because they've been trying to modernize their systems since the 1960s. Now let's go back in time.
Hey, maybe the fact that they've been trying to do the modernization from the 60s is a feature, not a bug.
What was happening in the 60s? Well, you had the rise of the population, the increase of Social Security and the like, and more organizations who were creating lots of paperwork.
Okay,
and so
yes, that's true. They were drowning in paperwork. Everything was done on paper. It was ridiculous. They were not. I'm surprised they scaled as long as they did, even with the computing power that they had. It's pretty impressive, actually. But yeah, trying to track on population, track and control, and tame and extract resources from, all with digital computers. Yeah, it's going to be a big job.
Realized by the late to mid 60s, there was simply so much going on, you couldn't do it by hand. I mean, why did banks used to close at 3 p.m.? Is they needed the time for the humans to reconcile accounts. The IRS was very much like that. And so there was, during the 60s, this period of...
Isn't that a nice bottleneck they got there, right? Trust us, we're counting all the money properly by hand.
Automation of human processes. And so most of that was written in IBM 360 assembly language. Zoom back to today, there is still code in the IRS system written in IBM 360 assembly language, running on emulators upon
Everybody's like, wow. It's like, I thought this was well known. Yes, the IRS is a piece of shit.
emulators upon emulators. But that creates really difficult problems
not
because some of that code...
I'm not going on a limb here. Not a very like unpopular. It's a popular opinion, right? Okay. I keep going.
Embodies
Chris, come on.
business rules that are within the assembly language itself. So how do you change that? And the answer is you're faced with a real human problem of how do I transmorgify old code in COBOL assembly language so that it can work on modern technology.
Transmorgify? You mean just transform, translate? Transmorgify. We're gonna transmorgify. What is transmorgify? Go, keep going, Chris.
There's only so much you can do via emulation. And then when you consider that the government, makes new business rules every year, how do you keep up with that? That's a real and present legacy problem. Facebook has the same thing, although their code doesn't date back that far. Google has the same problem as well. OpenAI will soon have that problem.
This episode is brought to you by WorkOS. If you're building a SaaS app,
Oh
that's
yeah,
what we're
you
working to
can go
building
over
it.
there.
Drop and replace. It's powered
Watch
by
the commercial.
today. Powerwalls.com, broke alternative. It is preview and some other holes
You
in
can go
information deployment
commercials
or
over
connections
there.
with preview deployments-based pricing.com. Can you give a sense of what types of companies you worked over the years, the decades, to help with their architecture, their legacy code, their tech debt?
Every conceivable domain truly is. I've had the opportunity.
Yeah, it's because it's a universal problem, because writing the code is different than maintaining the code. Now, all these people are like, oh, you can write it super fast. Yeah, but that's not the problem. That's only like 20% of the cost of these things. Is the other 80%, I hate to say it, is the maintaining of these bitches. Like, this stuff is crazy complicated. People coming and going, throwing their own ideas and everything's a mishmash. And it's not like academia has been very good about this. Like, we'll show you how a for loop looks. Data structures and algorithms are super important. No. I mean, that's all been abstracted now. So now it's all this: how do we maintain, understand, make it readable, make it comprehensible, make it extendable, changeable, modifiable, like figure out why is it crashing, like monitorable, all this other shit. It's like, that's boring. Yeah, but that's like, because that's where all the work is. Not this. How do we engineer it from the beginning? Yeah, we can write this shit super fast, but like updating it, understanding it, that's a whole other thing. And these AI tools are only going to do partial good job at this. I mean, they'll be better than what the manual, but it's still going to be like, what's going on here? And it's going to uncover graft, fraud, corruption. There's all these people backdoor deals, secret access codes, overrides.
Opportunity to work with, obviously, the financials. I've done a
What's
lot of work in the
this?
defense sector. In fact, to go way back in time,
USAID.
complex systems were really not started in the commercial realm, but they really began in the world of defense. The phrase I also use here is that all of modern computing was woven on a loom of sorrow. What we see in modern computing was born.
Oh, that's how I would put it? Look, man, computers were being used. Humans were doing the computing, doing the sorrow, whatever you want to call it, way before those electronic computers. They were doing logarithmic charts and all. They were telegraphing in. People were looking up the stuff. No, it just enhanced it. But yeah, almost all the technology we use, I hate to break it to you, are all based on wartime stuff. Oof. That's uncomfortable, isn't it? That unless we were killing people with weapons like mass, like missiles and guns, everything, we wouldn't have this technology. Yep. Welcome to humanity.
Born from World War II and the Cold War, particularly a system called SAGE, the semi-automatic ground environment that came about during the 50s and indeed was operational until the 1980s. This was a system built in response to the Soviet threat of them taking bombers over the Arctic and coming into the United States before we had satellites and pervasive radar. And that was a system that precipitated the creation of what we call the software crisis. It was what triggered the creation of the NATO conference later in that decade,
I didn't know this.
in which a group of folks came together from around the world saying, how do we attend to this problem? And it was really at the peak of what I call the first golden age of software.
Wow. So just the simple problem of detecting, ranging, and then coordinating where the tracking and the coordination of the missile sites, which will be launching, and then tracking those and seeing for detecting destruction or I mean, it's just a simple, very simple, straightforward problem, but they had to like have a conference just to get this part done, which would be like, I mean, we have a radar system. It's like not super complicated, but using the technology they had back then, oh yeah. Then they realized, oh shit, we need software for all this stuff. The hardware we have radar that tracks. We have scopes and screens that doesn't know where things at. But how we coordinate the information between all these damn things, they weren't even prepared for that. So I'm sure that's what most of the software they were trying to figure out is like, how do we do the APIs between all of these things? Who defines what does what? Where the responsibilities go, and where do you cut the responsibilities? And how are there going to be override systems? All that crazy shit. Yeah. You're going to need lots of coordination, especially if you've never done it before and you try to start to do it. You're doing your little part over here, and you just think the other person is doing this other part over here, and they're like, I don't know what you're talking about.
Software engineering.
Oh yeah.
So we have defense systems. I work with a lot of real-time systems, everything from pacemakers to
Good thing it was never actually tested. It was just doing all these little spoof stuff. There was actually no real attack ever. So we don't even know if these systems were operational.
To subway systems, to CT scans and the like.
They have no idea if it was working or not.
Truly, you name a domain, and I've probably spent some time in it. The James Webb Space Telescope currently uses the UML in its design. That's pretty freaking cool if you think about it.
Okay, so they used some diagrams for though that you'd invented, these little flow diagrams. They use UML. Universal markup language is those chart diagrams, really. After you promoted it for years and years and years and told everybody there's a way to do it, and it showed up on the software that switch it. Come on, this guy.
Being
All right, I'll
way
keep going.
forward,
He's all
you've
right,
now
I guess.
been working with a lot of companies, been involved in a lot of projects, and also influenced a lot of software architecture, the broader field. How would you describe the field evolving over the decades? You were clearly part of some key techniques invented and becoming commonplace. What was this like?
So I alluded to a phase I called the
Confusing.
first golden age of software engineering. This is the realm of
A lot of blowhards talking about a lot of shit that didn't make no sense that they had in their mind, but hadn't even written a line of code to even to actually demonstrate this works at scale that they were talking about. Like the little tiny projects, yes, no problem, but at scale. And they were like, no, just figure it out. Oh, it's the greatest thing ever. It's like, well, we tried it at scale, didn't work. Well, that's your problem. You did it wrong. Typical fucking cult shit. No, you didn't do the instructions properly.
the time of functional, or not functional, but algorithmic languages such as Fortran and COBOL, APL, Lisp, and the like, although Lisp was sort of a multimodal kind of language. But the dominant way that we decompose systems was through algorithms. And so you saw the rise of structured analysis and design techniques, which made a whole lot of sense at that time. This is where you had the Jordans and DeMarcos and Constantines and the like, because the presenting problem for software systems was they were generally not distributed. They were largely monoliths. And how could we build larger and larger systems that were sustainable and economically interesting over time?
Yeah.
Well, the
major problem. So there's the whole scaling issue. Yeah, if you're trying to do it procedurally, you're gonna have a real hard time. But the object-oriented stuff that Alan Kay was talking about, not the shit that went to C++, was Bootstrap. Not that crap. That was just C. That was just procedural with a little bit of flavoring on top, and then throwing the kitchen sink at anything that came up, trying to shove it in there. Half solved. Nope, you're doing it wrong. Sorry, this is correct. You can't figure it out. Well, you're too dumb.
golden age of that first golden age of software engineering began to change as we started to see the rise of distributed systems. And that rise, again, happened not in the commercial world, but it happened in the defense world. The ARPANET was, funded by the government, funded by DARPA. I was, as I mentioned to you earlier, I got my first.
Well, they were doing distributed stuff way before that, man. They were doing all these accounting systems. IBM, all these accounting systems. They would send their files back and forth and doing all that junk before ARPA. That's where ARPA kind of grew out. Like, oh yeah, it's a pretty cool idea where you can log in remotely. And then, so it's like, well, how can we just have a computer on both sides? And then that kind of where the ARPA thing came from, is from that idea. It's like, it's not really, oh my God, I connected two computers together. It's like, yeah, but they were connecting them together with proprietary shit for years before they're like, hey, maybe we should make a standard. Hey, maybe we should make it like open and not this proprietary shit. Oh, wow, it's an amazing idea. It's like, everything goes up. Of course.
Email address in 1979 when there weren't that many email addresses around. In fact, one small story there, when we had the ARPANET, I was teaching at the Air Force Academy at the time, we had a little mimeographed document that listed the email address of everybody in the world. I think at that time there were a few thousand people, so we knew who everyone was at the time.
Just for full disclosure, I got my first ARPANET email address back in 1987. I was working on this real estate company, and they were using ARPANET as this distributed system that go across the planet that would log in. I would send a message locally wherever they were, wherever the customer was around, and it would go through the ARPANET system and give them a ding over on their server. So they got routed around having to do all this crazy call-in mode, have their own modem architecture. They could do these sales tracking stuff with using piggybacking on the ARPANET. I don't think that was legal, but whatever. Nobody said anything.
It was pretty cool to go back.
Just emails.
So the first distributed systems were happening in that domain. Indeed, back at Vandenberg, I worked on a system called the Telemetry Integrated Processing System, which was a close network of some 32 mini computers. Mini computers were beginning to be a thing. And so the problems of how do I deal with taking a larger system and breaking it up into multiple distributed parts was beginning to emerge as a problem. Hadn't reached the commercial sector yet. So we saw...
No, it did. It did. It just wasn't on the internet. Which he's talking about, but they were doing all that stuff way before ARPANET. Like IBM was doing all.
The industry began to see that there were limitations to what one could do with algorithmic decomposition, and so there were these pressures all around to try to attend to the next kinds of software that was distributed, software that was real time, software that was multilingual, software that worked on a variety of computers. And I had to deal with all the normal aspects of distributed systems.
Yeah, that creates standards. That's about standards going from proprietary systems that were locked in with thousands of dollars. We're talking about sales here. I know it's like hard to understand. Like a lot of this stuff is sales driven. Like the Defense Department, they were like, "Oh shit, we got this problem with Soviet Russia. We're make it seem like we got a problem with Russia, and we're gonna make it like pumping all this money into these defense contracts. Well, who's gonna run most of this stuff is software, so it's like, okay, well, but you're gonna have to like figure all this shit out. So that's where the DARPA stuff was like started on. That stuff was like, how do you make a nuclear attack proof? And that was the whole reason the ARPANET started in the first place, and it became this other thing later. And it was by accident. Nobody was planning ahead. But it was kind of inevitable. I mean, we had a telephone network. It looked exactly the same. It wasn't that big a difference. It's like, oh shit, it's so different. It's like, not really.
Which is they're going to fail at various times and about communication issues and the like. So it led to a realization that we needed to think about software in very different ways. The other thing that was happening is in research, you saw the rise of languages such as Simula and Smalltalk, which were looking at the world in fundamentally different lenses. So here we are again in the late 70s. Yeah. And again, I'm a 20-something. I was asked by one of my former teachers at the Air Force Academy, say, Grady, would you go help the Department of Defense figure out how to use this new programming language called Ada so we can apply it to modern software engineering techniques? Now, why was the government worried about this? By that time, software was a real problem for the Department of Defense, actually for all of the federal.
Yeah, because the way they were writing it was assembly and C and all its procedural style and not having the people have like a widespread understanding how networking works. That was all hidden stuff. It wasn't publicly available. There wasn't nobody talking about it unless you're in the DARPA program or they were tapped on by. There was not widespread knowledge about this stuff. People weren't doing the hacking thing. Everyone was working on their own little box. So doing the networking thing was like, what are we doing here? And also the power there was like the speed of transmission was just like, this is not useful, guys. It's got to be fixed. The transmission speed has got to be way higher. And before that, so there was a lot of this gating of like the speed of transmission and for economically. It was all economics. I don't know.
Government, because there were several thousand languages in use that exploded because Fortran and COBOL were useful for some things, but not for all.
Right, and also that you could get really popular and famous by writing another variant of all of the same crap that was already out there. Everyone had their own little special language because it was all this proprietary shit because this was sales driven, man. And also cloud driven. There's people who could write a new language. It wasn't really that hard to make a new language. First of all, let's get that real out of the way real quick. Back then, what they considered a language, I mean, I was in what? 9th grade, 9th grade at a high school in Maine. I had a TRS-80 Model 1 for about a year. And I wrote my own language, a graphic programming language. It's called GPL. That's what I called it. And it was about, you had to write this little routines of code that would write and do graphic stuff on the screen. And I wrote this when I was 13. So let's not get ahead of ourselves about the language. I wrote a language.
Things. And so there was a decision made to build one language to rule them all, and that was the Ada programming language.
And they always
Ada
tried
was
to do this.
far ahead of its time. It was
I mean, now get me wrong, Kotlin is my favorite because of what it lets you do, right? It's not the general purpose. It is general purpose, but it's really focused on doing web applications, mobile development across platform. So if you want to do that, you should really think about using Kotlin because you can write 80, 90%, 95%, 100, 98, 99% of your code in one language. And then the edges that have for iOS and for Android and for the web, whatever, those little gotchas and little side, except sort of you have to do it like this. That's all handled in those specific languages that are just for those native environments. So I don't think we're ever going to get away from the one language to rule them all. I don't think it's possible.
Language that was influenced by Simula and Smalltalk and others, but it used the ideas of abstract data types from Liskov and Galgan and others. It used the ideas of information hiding from David Parnas, all ideas that were very new at the time, but frankly are part of the atmosphere in which we breathe right now. And so as an industry, we really didn't understand the methodologies.
They were kind of like the obvious next step if you have to deal with this crap for a while. It's like, it wasn't, oh my God, you discovered everything. It was like, impossible to discover. A lot of these things were just like floating around by people trying to do stuff, and we just kind of would talk about stuff. So when somebody's, I invented it, like the solid stuff from Uncle Bob, whatever, he didn't invent that shit. He even admits he's like, I just picked these ideas from other people. I was a cataloger, I'm a programmer, but also cataloging. I realized other people had these insights that I could just put into a book and then get clout from. I mean, I don't know if you understand, if he was trying to do that from the start, but that's definitely what it turned into.
To make that work. Thus was born the Booch method. I was in 79 till about 81. I was going back and forth across the United States, helping the federal government and helping contractors try to apply this new language in new ways. And this was the beginnings of the second golden age of software engineering, in which it was not so much the complexity of the algorithms, but it became a systems engineering problem, systems that were dealing with distributed systems that were very new at the time. And that was the essence of the Booch.
Well, it was just the tools, man. The tools that were available, and still the tools that are available are not that much different than how they were doing it back then. It's just to expect the scaling to happen and the amount of communication that has to happen by having like bouncing on a language or data structures or distributed systems. That's not happening at all. It's the boundaries, and I'm surprised he hasn't brought this up yet. It's the transmission boundaries. It's the APIs. It's how do you talk to another system without having to know all the details of that system? How can you hide data hiding? It's like, yes, you have to have some sort of boundary so different teams can work on their individual things through a common set of interfaces. Like when you, I go into the full details on my course, how to program from the ground up. I go into all the detail about the difference between this procedural styles, the CS, C++, data structures, algorithms, down in the trying to do distributed systems, all that junk to get away from that and do the Alan more of the Alan Kay style, which is I'm surprised he's talking like this. And he's touting Alan Kay when he's still talking like a C++ programmer. Let's keep going.
Method. It was the things I learned about helping organizations architect systems with these new kinds of domains and new kinds of languages.
Could you explain what the Booch method is? I understand it has to do with object-oriented programming, but coming from you as the person who invented it, it would be nice to explain what it is and why it was important.
Well, let's go back to Plato. Talking about going way back. I wasn't around then, but I've read about him a little bit. There's this wonderful treatise he wrote, The Dialogue, in which there's a debate about how one should best look at the world. Should I look at it as atoms, or should I look at it as processes? Well, the first golden age of software engineering was more focused upon the processes, the algorithms. But there's a parallel way of looking at the world, and that's looking at it through the atoms, if you will, the classes and objects within them. So yes, I was influenced by abstract data type theory, by Plato, by a lot of other interesting philosophical things that were coming together at the time.
Well, that's a stretch to put those together. I don't know. I'm gonna have to I don't even need to explain how he's putting those together. Now, if you're trying to use it as a metaphor, yes, okay. But I would say that even more be like the previous program was atoms. Of like how do atoms interact with in themselves, and then above that it becomes philosophy. How do we interact with each other and be friendly with each other, and we can work together? That's more of a philosophical bent. I don't know. He's kind of stretching that metaphor a little too much.
Of looking at the world in fundamentally different ways. So the Booch method was really trying to codify that. How can we decompose systems not based upon algorithms, but how do we decompose it based upon classes and objects? And
why is he got to call it the Booch method? Really, the Booch method about decomposing a system into its components and processes? This is the Booch method. More like bleh method, the Booch.
Again, that's where I was in.
Why is this? So this is like the little bit of this ego going on, and okay, some of it's deserved. Other stuff is like, dude, could you chill out on the Booch method about decomposing your program into systems and subsystems and APIs and bridges and like boundaries? The Booch method.
Influenced by Liskov and Parnas and Dijkstra and Hoare and the like, names that are probably unfamiliar to students these days, but they were representing the theoretical underpinnings of the first and second.
But not that useful. Turns out, not that important. Oh, an interface? You define an API? We're going to Liskov institution. It's the Liskov substitution. No, it's just an API, man. No, it's an interface. It's good. It's just an API. It's like, hey, I'm expecting these things, and if you're providing these things, you better do all the stuff you say you're going to do. What? This is a contract. That is the main thing. And then how do we put these things together so they're modifiable, like for understandable, so we're not overloaded like a 10 billion things. This interface does it all, right? That's the interface segregation thing. It's like you don't want every goddamn thing in there. Just the thing you were trying to do as a with the agreement. I want to call up my energy company, my energy company, say, what's my bill? Have I been paid? Am I in arrears? Can I make a payment? Can I make an extra payment? Can I make? That's what I want to know. The things I want to ask is the API, right? And there might be an other that's going to have another set of APIs, right? But there's going to be a standard set of things like how do we communicate with each other? Do I need to go down there and fix it myself? I don't want to go fix it myself. I want you guys to fix it. That's why I'm paying you. So you guys maintain that whole thing. And the API I get to talk to, I don't get to go and drive the truck out to the line and fix it. No, I have to call somebody and say, hey, could you fix my line for me?
In generation. The Booch method was basically saying, hey, here's a new way of thinking about the world. And so it said, look not at algorithms, but look at combining data and and processes, algorithms together in one thing, thereby classes. Now we did some things.
Ugh. Thereby classes. Is that the only way you can combine the things? Okay. Let's keep
Right,
going.
we did some things wrong. I think the things we did right was classes make a lot of sense in terms of abstraction. What we did wrong
For certain types of problems, but not all problems. Holy shit, man. Like, this is what happens. Like, this Booch, you gotta got the Booch method. This is where they get this, like, so programmers go, oh, the Booch method will solve all my problems. He's like, yes. I have been all over talking to all kinds of defense contractors with the defense contractor types of program problems. And I've decided that the way out is for you to follow the Booch method, which means you have to use classes. Really? Really? So all problems are Booch problems? Okay, well, that's very convenient for you, sir.
is we overemphasize the notion of inheritance. Inheritance was all about let's save code because we can
No, see, that's the thing. It was not about save code. That was what it turned into and was promoted by another programmer called Stroop who was trying to save his language. I'm C++, gotta save it. So he puts every damn thing in there, including this notion that, oh, you can save code. Now, they keep saying it doesn't, it's not for that. It's like, yes, that's what it turned into. This inheritance thing. So, I can, the millions of dollars I just spent, I can just extend that and not have to rewrite it and figure out what's going in there and just put an onion around it. This is what they said. This is what they promoted. Now we figured out. It's like, oh, that's bullshit. Yeah, that's not a thing. That's not how it works. We're not, like that's ridiculous. It's silly. It was a kayfabe. It was a famous.
build generalizations.
You can't extend. You can't continue your code, and they have it. You might do that twice. You might be able to do the inheritance thing twice, and then you got to start over, right? Because it's like you're doing it all over the place. It's like, I'm using this one from here, this one from here, and this class up here, and this part of the hierarchy over here. Oh, it's simple. I have to know about 65 things at once. And they're like, this is going to solve the engineering problem. It's like, no, it's not.
The like that proved to not make a lot of sense.
Yeah, no shit. But you guys pushed it super hard, and you made it a big deal for a long, long time, to the point where people still have to talk about it today, even though it's been out of favor for many years. But we still have to deal with it because of the guys like it was like, oh, well, it turns out it was a bad idea. Oh, but you promoted the shit out of it, but you didn't do the opposite. You didn't go back and say, hey, that inheritance thing, that's really not part of the object-oriented stuff we were talking about. It's just a way to do like shallow hierarchies to kind of put things up, but it's not saving anybody's code. We're not reusing code. Never came back with that. Nope, just kind of figured out. Nope, you figured out your own. Nope, we don't know what. Oh yeah, that was a bad idea. It's like, what other ideas do you have that are bad? You're gonna have to demonstrate everything that you talk about that's gonna be amazing and great. You better demonstrate it with large scale stuff. You gotta pay IBM, your billions of dollar company. Go run some fucking studies. And the reason they don't is because shit don't work like that. It don't work the way they say. They're confused. The fact of the matter is, you have to have people who have been doing this kind of stuff since they were kids, being hands-on, solving actual real problems, not this fake crap that they push us into like public school. Real problems with real people, with all the things, and then we decide from that, we kind of figure out, hey, there's some things that work. And most of the stuff he's talking about is like the stuff I'm referring to is Alan Kay's ideas about these things, which we have not seen yet. We've seen flavors of it, like tastes of it, but we've not seen the full thing that Alan Kay's talking about. So we're not seeing the full computer revolution yet. These computers are still all black boxes. These apps are all black boxes. We'll give you a little API, but no, I want to take over the whole damn thing. I want to make it my own. I want to change it around, make it my own thing. Until that happens, we haven't seen the computer revolution yet. We're still ways away from that.
Doing lots of disparate kinds of abstractions. That's okay. Fast forward to today, and people say, well, what difference does it make? And the answer is, it's part of the very atmosphere in which you breathe, and so you don't even think about it. You look at, Redis, and you may build things upon it, but, if you look at it, you're really dealing with a set of abstractions that Redis offers you, and those abstractions are class-based. So they're baked.
Is it class-based? Is it all for class-based? And that's the only way to do it, really? I find he's pushing these guys. He's ideological. So he's pushing his ideology of classes and objects, and like all problems will be broken in that way. And you're right. The same way that procedural can break every problem down that way. But does it make it extendable? Does it make it modifiable? Does it make it understandable? Probably. I mean, this class-based thing. I don't know, man. It has its ups and downs. Like a lot of the code, I think 85% of it should be all just batch procedural stuff. And the other stuff that you really need to do, this object-oriented stuff, is to be really cautious with any of it, because the way it's promoted and the way most people have learned it is like not the Alan Kay way. It's the C++ static variable access, like, oh, just for performance.
The way of thinking of those kinds of systems. So in short, the Booch method was, let's look at the world not through algorithms, but instead through objects and classes. The last thing I'll mention is one of the things the Booch method hinted at that really did not catch full form into the UML was looking at systems through multiple points of view. Now, we'll come back to that in a bit when I talk about
Oh my God.
So just so I understand, because myself and most of us listening will have started our careers long after the Booch method was invented. For us, classes, variables, inheritance, that's pretty common, pretty everyday.
All right, I'm going to finish this, and I'm going to do part 2. Because this is too crazy. It's just, okay. All right, I'm going to finish this. All right, give me a like and subscribe, and I'll see you tomorrow with the more of this goofiness.